This is video number 2 for the third sample exam for Math 107. For problem number 12, you're given a polynomial and you're given a root. Then the idea is to use long division to factor the polynomial into this form. I want to go over what this form means. So let's do the long division. I know the root, which I'll call R1. So x minus R1 is going to divide, and let me put the polynomial, it's going to be in red. Okay, there's a reason for this. And once you get through doing this division, you end up with another polynomial up here, which I'll put in green. And what other colors do I have? Whoops, I'll have to use blue again, I guess. So you go through this whole thing, and you end up with some remainder. Okay, if it's a root, this remainder is 0, but I'm going to get there in a minute. So let me do it let me do this with numbers, because you'll understand what I'm doing with numbers. Let's say I have another division problem, and I'm dividing 25, and I'm going to divide it by 4. If I divide it by 4, the answer is 6, and then when I carry out all this division, I get a remainder of 1. I could write 25, so we got that, equals 4 times 6, back to plus 1. Okay, the 4 times the 6, and then I add in the 1, the remainder. I'm going to do the same thing up here, but I'm going to do it with just symbolically with letters. Okay. So in this case, we have the polynomial, what's being divided, equals the divisor, x minus r1, so just stick that there, and the answer was q, so I'll put the q of x here, and then I have to, there's an x here, and then I have to add in the remainder. Okay, you see how that goes? The 25 equals 4 times 6 plus 1. P of x equals x minus r1 times q of x plus the remainder. The only difference here is that if this is truly a root, the remainder is 0, so you don't have this last term. And that's what is written right here. So the idea is to take this polynomial, divide by 1 minus a negative 1, which will be 1 plus 1, find out what polynomial you get left over, and write it in that form. So I have to do the long division, and it's x minus the root. The root is negative 1, so it's, let me write this up here so you can kind of see this. X minus a negative 1, that's going to be x plus 1. Right. So here's your x plus 1 here. And I'm dividing, what I got here is x cubed plus 3x squared plus 3x plus 1. Now what does it take to turn x into x cubed? Well, multiplication by x squared. So x squared times x gives me the x cubed as planned. X squared times 1 is just 1x squared. Now remember again, this is where mistakes get made. You're doing subtraction. X cubed minus x cubed, that's 0. 3x squared minus 1x squared gives me 2x squared. And bring down the next term. What turns x into 2x squared? Multiplication by 2x. So I have 2x squared plus 2x. Subtracting again, 2x squared minus 2x squared, that's nothing. 3x minus 2x gives me an x plus 1. Alright, and this turns into a 1. 1 times x plus 1 is x plus 1. I'm done. The remainder is 0. It is indeed a root. Now I want to write it in this form. So I've got x cubed plus 3x squared plus 3x plus 1 equals x plus 1, remember I got that from here, times, and don't work it out, just write it like this, the polynomial that's up here, the answer, x squared plus 2x plus 1. After you've done the division, that q of x, that answer, is a polynomial of a degree less than, one less than the original. And a lot of times that's easier to factor, and that is the case. So here the polynomial we wrote with the x plus 1 because that was the root. The first root was minus 1. And then we had this, x squared plus 2x plus 1. Well, this is easy enough to factor. All right. It factors as x plus 1 times x plus 1, right? X times x gives me the x squared. Then you have 1x and another x, that's a 2x. 1 times 1 is 1. There's my answer. Now it is fully factored. And what are the roots? Well, the first one was x equal minus 1. Here's the first root. What's the root from here? What is the value of x that makes this 0? It's negative 1 again, and it's negative 1 again. So the roots, which you can write are 1, 2, and 3, are all equal to minus 1. So the way that's stated is you have a root of minus 1 with a multiplicity of 3 because it occurs 3 times. Now if you remember above, we had that polynomial in a fully factored form. So it looks like this. X minus the first root times x minus the second root, on and on like that. For its number of roots that we have, it, of course, if we have a polynomial of degree 4, we'll have 4 terms like this, 4 factors. In this case, you're given these roots, and the idea is to write the polynomial of lowest degree that has the following roots. Well, a higher degree, okay, the minimum one is going to be 4 because there's 4 roots, right? A polynomial of, say, 10 could have these roots if they had multiplicities, right? But we're going to write the lowest degree. So it's x minus the root. The first root is 2, so it's x minus 2. Then it's x minus a negative 5, which would be plus 5. And now this next part, when you look at it, if the root's complex, which this is, you always have to have complex conjugate pairs, and you do. If this one hadn't been given, you would have had to add it in, because anytime you have a one complex root, you have to have its complex conjugate in the list as well. Right. So now I'm going to write the next. It's multiplied, but I got to go down here because I ran out of room. It's x minus, and here's the root, 3 plus I. See that? And the next one is x minus 3 minus I. And that's, leave it like that. Okay, that's perfectly fine. Sometimes people get a little problem with this. Use the pattern. It's x minus the root. So put the x, put the minus, and put the root in here. If it's complicated, use parentheses. On the previous question, all you had to do was write it out in that factored form. Here you have to write it in the factored form, and then you have to multiply it out. And you get 2 separate problems here. Now here was what I was discussing before. Some of the roots of the polynomial are 2 and minus 1. Find the missing root or roots and write the polynomial in factored form. Well, if there's roots 2, I can't deduce there's any other roots. But if minus I is here, then its complex conjugate, which is I, has to be there. Remember, minus I is a complex number. It's really 0 minus 1i. The complex conjugate of 0 minus 1i is 0 plus 1i. So you can abbreviate this as negative I, and this one is just positive I. Okay. So now that I have the missing root, so here are the roots 2 minus I and I. And now I can write the polynomial in the factored form will be x minus the first root is 2, so it's x minus 2. In the next case, it's x minus a negative I. And the next time, it's x minus I. And now you need to multiply this completely out. The way to do it is to multiply, let's just do any 2 together. I'm going to leave this alone. And FOIL, x times x gives me an x squared. Then I have x times negative I plus x times positive I. The cross term is gone. And the last term is minus I squared. Let me write that out in case you are unsure. That's a minus, sorry. I. So, foiling, I get an x squared. Then I have x times negative I, which is minus xi. Then I have I times x, which is the same as plus xi, doesn't matter the order. And the last is minus I squared. All right. So I get the x squared, but you notice these cancel out. And then the next term is minus I squared. What's I squared anyway? I squared is negative 1. So I have x squared minus a negative 1, which is the same as x squared plus 1. Right. And that's what's shown right here, but I just wrote out all the terms. And now let me do the rest of the multiplication. Let me erase some of this for room. Okay, so I've multiplied, I've got x minus 2, and this is x squared plus 1. And now I FOIL this. X times x squared is x cubed. X times 1 is 1x. I'll put the 1 in here for people who like to see it. Minus 2 times x squared is minus 2x squared, and the last term is minus 2. All the terms are different. There are no similar terms to combine, but you should write your polynomial in either ascending or descending order. And so I'll write it in descending order. X cubed minus 2x squared plus x minus 2.